Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 1 and 1.5 and what's called proof by deduction. Now, what is a proof? Well, a mathematical proof is a rigorous argument made up of logical steps which unequivocally demonstrates the truth of a given proposition. An unproven proposition is called a conjecture. A proposition which has been proved is called a theorem. Now, there are several different types of proof, and you'll meet several of them when you take A-level maths, and even more if you choose to take further maths. In this lesson, we're just looking at what's called proof by deduction. Now, what is it? Well, it's a process where a statement is proved to be true by using well-known mathematical principles. You will have used proof by deduction many times, answering all sorts of questions without knowing that that's what it's called. It's essentially what we do when we show the working for a maths question, where we've been told the answer to the question in advance. So we know what the answer is, but we've just got to show how we get there in a neat, logical way. Let's have a look at an example. So example 1, prove the identity 2x cubed plus 3x squared minus 11x minus 6 is identical to this. Now, a couple of things before we have a go at this. First of all, what's meant by an identity? Well, an identity is not an equation. An equation is something which is true for some values of x, and you have to try and find those values of x. But with an identity, you're not expected to try and solve it. It's true for all values of x. So rather than there being a particular value or set of values for which it is true, it's always true. Now, to prove an identity is true, the best way to write it down is to choose to start either with the left-hand side or the right-hand side. If you start with the left-hand side, you then keep on manipulating it until you get the right-hand side. If you start with the right-hand side, then you manipulate that until you get to the left-hand side. And at the point where you've said, well, the left-hand side does equal the right-hand side, you've completed the proof. Now, there's nothing hard in this question. It is as easy as it looks. The only thing that might be a little bit new to you is the way we write it down. But I'll let you have a go at doing it yourself first. There are no tricks, there are no catches. Do the most obvious thing and you'll probably do it right. But have a go, pause the video and come back to me when you're ready. Okay, let's have a look at this. So we're trying to prove that identity. The main question that you have to ask yourself, or decision you have to make when you're proving an identity, is do I want to start with the left and try and change that so it becomes the right, or do I want to start with the right-hand side? And normally one of those is easier to do than the other. In this particular question, it's easier to start with the right-hand side. So start with the brackets, and then all we have to do is multiply those brackets out and show that when we've multiplied them out, we do get the left-hand side. So multiplying the second two brackets together, I'd get that. Tidying that up would give me that. And then multiplying those two brackets together would give me all of that. And again, tidying all the terms together, collecting them up, I get 2x cubed plus 3x squared minus 11x minus 6. Now, I started with the right-hand side, and I've worked at it, and I've manipulated it, and I've ended up with what I've got on the left-hand side. So I started with the right-hand side, and I've proved that it's equal to the left-hand side. If you have an identity to prove, that's the way you should write it down. And at that point, we've finished the question, but you should just include one more line, which is a statement that we have proved what we've been asked to prove. So therefore, this does equal this, or is identical to this. Okay, example 2. Prove that if x minus a is a factor of f of x, then f of a is equal to 0. Now, we met this a couple of lessons ago. This is the factor theorem. So we're being asked to prove that the factor theorem is true. That if x minus a is a factor of f of x, then if I substitute x equals a into the function, I will get 0 for the answer. Now, this is a little bit more confusing than the last question. I'll let you have a go at doing it yourself first. It doesn't take that many steps, but as I say, it will feel a little bit more confusing than the first question. Anyway, have a go, pause the video, and then come back to me when you're ready. Okay, let's have a look at this and how we write it down. Well, if x minus a is a factor of f of x, what does that mean? Well, if 3 was a factor of 15, it means that we could write down 15 as 3 times by 5. We do something similar here. If x minus a is a factor of the function f of x, then we can write down the function as x minus a times by something. And g of x there is just saying some function of x. We don't know what it is, we don't need to know what it is. But if x minus a is a factor of f of x, then we can write down the function as the factor times by some other factor. Now what about f of a? Well, f of a is saying let x equal a in the function. So f of a means substitute x equals a into what we have here, which will give us a minus a times by g of a when I let x equal a. But a minus a is equal to 0, so that'll give me 0 times by g of a, which gives me 0 for the answer. Now we've done what we were asked to do. We've assumed that x minus a is a factor of f of x, and what we've shown is that if that's the case, then f of a must equal 0. And these are the logical steps that you should write down. A little note on this. When we're doing proofs, there are a couple of symbols that are useful, and one of them is the symbol for implies. So that just says this implies that f of a is equal to 0 times g of a. And that says this implies that f of a equals 0. It can be a useful shorthand when you're writing down a proof. As always, when you finish a proof, the last thing you need to do is just make it clear that you've proved what you would be asked to prove. So you just make a statement of the proof. Therefore, if x minus a is a factor of f of x, then f of a does equal 0. Okay, example 3, different type of question. First of all, there's a statement at the top, which is the definition of a parallelogram. Given a quadrilateral ABCD, if one pair of sides are the same length as each other and parallel to each other, then you will have a parallelogram. So you don't have to prove that. That's just a statement about what's required to prove that a quadrilateral is a parallelogram. And then example 3 says, prove that ABCD are the vertices of a parallelogram. Now looking at the statement above, that means we need to choose a pair of sides. Now when I do the question, I'm going to choose AB and CD. I need to prove that AB is the same length as CD. I also need to prove that it's parallel. Well, how do I prove that it's parallel? I find the gradient of the two lines. So I'll find the gradient of AB, the gradient of CD, show that they're the same as each other. The length of AB, the length of CD, show that they're the same as each other. And if both those things are true, I must have a parallelogram. Okay, I'll let you have a go at completing all of that yourself. So pause the video, have a go at completing the proof, and then come back to me when you're ready. Okay, let's have a look. So I've made a quick sketch just to show roughly what the thing looks like. So I've drawn A, B, C, and D as shown there. It's not essential, but it's sometimes nice to have a sketch with any geometrical question, just so you can see vaguely what's going on. First of all, I found the length of AB, and the length of AB is the square root of 5 minus 1 squared plus 8 minus 5 squared, which gives me the square root of 4 squared plus 3 squared, which is root 25, which is 5. So the length of AB is 5. And that's just using the standard formula for the length of a line joining 2 points together. It's using Pythagoras' theorem. Same thing for the length of DC. So the length of DC will be the square root of 6 minus 2 squared plus 5 minus 2 squared, which also simplifies to 5. So AB and DC, they have the same length as each other. So if I was to join those 2 points together and those 2 points together, they'd be the same distance. I now need to show that AB goes in the same direction as DC, that it's parallel to it. To do that, I need to work out the gradients. So first of all, the gradient of AB, that's equal to the change in y divided by the change in x as you go from A to B, which is 8 minus 5 over 5 minus 1, which just gives us 3/4 for the gradient. Same thing for DC. Gradient of DC is the change in y over the change in x as we go from D to C, which is 5 minus 2 over 6 minus 2, which also gives us 3/4. So AB and DC, they are the same length and they are parallel to each other. Therefore, A15, B58, C65, and D22 are the vertices of a parallelogram. And that would be the proof completed. Question 4, again, a very different type of question this. Given that the quadratic equation, kx squared plus 3kx plus 9 equals 0, has 2 repeated real roots, prove that the only possible value of k is k equals 4. So we've got a quadratic equation. There's a value k that we don't know, but we're told that the equation has got 2 repeated roots. And we have to prove that the only possible value of k is k equals 4. First of all, it isn't sufficient just to show that k equals 4 works. So we could substitute k equals 4 into there and show that it gives us a quadratic equation that does work, that it has 2 repeated solutions. Now, the reason why it isn't sufficient to do that, if we do that, this would prove that k equals 4 is a possible solution. It would not prove that it is the only possible solution. And we've been asked to prove that k equals 4 is the only value that will work. That means we need to go back to what it means if a quadratic equation has got repeated roots. Well, if a quadratic's got 2 repeated roots, what that means is that the discriminant, b squared minus 4ac, must equal 0. Now, to work out the discriminant, we'll take the values of b, a, and c from the equation, substitute them in. That will give us another quadratic that we have to solve, and then see what you get when you solve that. Okay, I'll let you have a go at finishing this proof. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look. So we're trying to prove that k equals 4 is the only possible solution and the only possible value that will give this quadratic 2 repeated roots. 2 repeated roots means the discriminant has to equal 0. The discriminant is b squared minus 4ac, which in this case will be 3k squared, that's b, minus 4 times k, which is a, times 9, which is c. So I get a quadratic in k. If I multiply that out, that'll give me 9k squared minus 36k equals 0. That I can factorize, taking out 9k, which gives me 9k times by k minus 4 is equal to 0. And then when I solve that, there are 2 possibilities. So either this first term, 9k equals 0, which means that k is 0, or the other possibility is k minus 4 equals 0. So either k equals 0 or k equals 4. Now, we've been told we should only get one solution. So why is it we've got 2? Well, if we look carefully at k equals 0 and what happens if k equals 0. If we substitute k equals 0 into the quadratic, we'll get 0x squared plus 0x plus 9 equals 0. Now, both those first 2 terms will vanish because we're multiplying by 0. Now, there's 2 issues there. The first issue is, if k equals 0, this will not be a quadratic equation. And the second issue is, it's not even true. If k equals 0, we end up with 9 equals 0, which is just an untrue statement. So it looks as though there are going to be 2 possible solutions, but one of them is impossible. The only possible solution is actually k equals 4. And then you finish the thing off by saying, therefore, if the quadratic equation kx squared plus 3kx plus 9 equals 0 has 2 repeated real roots, the only possible value of k is k equals 4. Now, that is the end of the question. That is what they've asked us to do. But it's worthwhile just substituting k equals 4 in to see what's going on if k is 4. So if I substitute k equals 4 into the quadratic, I get 4x squared plus 12x plus 9 equals 0. And that does factorize into two identical brackets, 2x plus 3 times 2x plus 3. And I get the repeated solution or repeated root of minus 3 divided by 2. Okay, example 5. It starts off with a statement in speech marks, and the statement is this: 2 is the only number which gives the same answer if you square it or if you double it. So 2 squared equals 4, and 2 times 2 equals 4. And then we're asked to prove that the statement is false. It does look as though it's true. So if you square a number or if you double it, you've got to get the same answer. So it works with 2, because 2 squared is 4 and 2 times 2 is 4. 3 squared, for instance, is 9, but 2 3s are 6. 1 squared is 1, but 2 1s are 2. 10 squared is 100, but 2 10s are 20. Feels like every other number does give you a different answer. But if the question's correct, the statement is false, and then the question is, well, how do we prove it's false? What we need to do is change this into an algebraic statement. Now, algebraically, the statement is saying that x equals 2 is the only solution to the equation x squared equals 2x. Because that's saying if you square a number, you've got to get the same thing as if you double that number. And then you move on from there. Now, I'll let you have a go at guessing exactly how you move on from there and how you prove the statement is false. So pause the video, have a go at finishing this, and then come back to me when you're ready. Okay, let's have a look. So we're trying to prove that 2 is not the only number, which gives the same answer if you square it or if you double it. And to do that, we're looking at the algebraic statement, which is saying the same thing, that x squared has to equal 2x. Well, if x squared equals 2x, just moving the 2x to the other side would give me that, which implies that x into x minus 2 is equal to 0 when I factorize it. And this has two solutions. It has the solution x equals 0 and x equals 2. Now, unlike the last question, x equals 0 is not a problem. So it's certainly true for 2, that 2 squared is equal to 2 times 2, but it is also true for 0. If we square 0, we get 0. If we double 0, we get 0. So you do get the same answer if you square 0 as if you double 0, which is what we're showing here. Therefore, 2 is not the only number which gives the same answer if you square it or if you double it. And so therefore, the statement is false. Okay, that gets us to the end of this lesson. Now, if you've got the textbook, then turn to page 16 and have a go at exercise 1E. Thanks very much for listening, and cheerio.